Hello everyone and welcome back again. Today I'm going to help you solve an interesting question on surds. This is a topic that deals with a lot of students in such that they become so scared of it. But you don't have to worry. I am here to make it easy and very simple for you to understand. Without further ado, let's answer the question. The question reads, if 3 plus root 2 over 3 minus root 2 equals a plus b root 2, where a, b, and c are rational numbers, show that 6a minus 6b over b equals 5. Now, there are a couple of things we must do in order to be able to answer this question and to show this at the end. The first thing that we need to know is that we have to rationalize the denominator first of this very expression here. That's the first thing that we must do. Okay? When we rationalize, we have to express it in its simplest form, which is a plus b root 2. When we express it in its simplest form, then we have to compare it to what we have on the right hand side, right? So whatever attached to the root 2 becomes our b, okay? And whatever that is not attached to the root 2 becomes our a. So we must express this in its simplest form before we can be able to extract our a and b. Then when we find our a and b, we then substitute those values into this expression here. So the a goes to the 6 and the b also goes to the 6. So you also divide them by the same b and you now check if it equals 5. If it is true, then it should equal 5. But if it is not true, then it's not going to equal 5. And that means you have to reevaluate your solution. Now let's get right into it and start solving this very problem. Here I'm going to say solution. First, like I said, we have to rationalize. Right here we have 3 plus the square root of 2 over 3 minus the square root of 2. So we have to rationalize the denominator to express this surd in its simplest form. So we multiply by the conjugate. Now, why am I doing this? It is not proper to leave the denominator of a fraction as an irrational number. And as a result, we must find a way to remove it from here. So we simply multiply by the conjugate. The conjugate is simply changing the sign. If it's a negative down there, it becomes a positive. If it's a positive, it becomes a negative. So let's multiply the top and the bottom by the conjugate of the denominator. Here we now have multiplied by 3 plus the square root of 2 over 3 plus the square root of 2. Let's now expand. So here we have 3 times 3. This is a 9. Then plus 3 again times root 2 gives us 3 root 2. Okay, the 3 multiplies the root 2. When you have something like this, let's say 3 root of 2, it means that this 3 is multiplying the square root of 2. That is what it means. Okay, now let's go again. Root 2 times 3 will give us plus 3 root 2. And then root 2 times root 2, this is going to give us the square root of 4. Let's just take it this way, step by step. I know some people would want to write it 2 there. It's still okay, it's still correct. But for those who are still new to this concept, it's better we write it this way. Now this is over. Let's now multiply the denominator. Here we have 3 times 3 is a 9. And again, 3 times root 2 will give us, as usual, 3 square root of 2. And again, minus root 2 times 3 will give us minus 3 root 2. Okay? And lastly, minus root 2 times root 2 will give us minus square root of 4. Okay, so it's now time for us to start cleaning them up. Here we have 9 plus. So if you look at this closer, you discover we have two like terms on top. Here we have root 2 and root 2. They are simply the same. So what do we do with them? We add them up. This one here is a 3 root 2 plus 3 root 2. They are simply the same. So we add them up and say plus 6 square root of 2. Okay, because they are the same. Just like when you have 3x plus 3x, it gives you 6x. That's it. Now we say plus the square root of 4 is simply a 2. Okay, and this is over. Right here we have a 9. So 3 root 2 minus 3 root 2 equals 0. You can see root 2, root 2. Focus on what is inside, okay, the roots. If they are the same, you can add or subtract them. But if they are not the same, they are called unlike terms and cannot be worked on. That becomes the final answer. But since they are the same, you can subtract them. So 3 root 2 minus 3 root 2 equals 0. We can drop them, and we're now left with the square root of 4 is simply a 2. Okay? Now let's continue and see how far we can go with this. Now here we have 9 plus 2 is 11, so we have 11 plus 6 square root of 2 over 9 minus 2 is 7. Now let's see how to split them apart or break them apart. Here we have, since they have a common denominator and there are two terms on top, you can see this one is the first term and 6 root 2 is the second term, so we can simply split them apart and then see if we can obtain our A and our B. Here we have 11 over 7 plus 6 root 2 over 7. Okay, good. So we've now split them apart. And what does this actually mean? So this means that if we compare this to what we were given in the original question, it says that we have to compare it to A plus B root 2. So this means that the number attached to the root 2 is our B. So the other one attached to the root 2 is our A. We can now say that A is equal to 11 over 7, and then our B is equal to 6 over 7. So this is just how it works. Once you have expressed the surd in its lowest term, then the next thing that you have to do is to compare it to what you were given in the original question. You've seen the one attached to our root 2 is our B. And what's the number? 6 over 7. Now, the one not attached to the B or not attached to the root 2 is our A. And what is it? 11 over 7. Okay, so let's now see if we can solve it and find out if it equals 5. So this is the part 2 of the question. Let's see if we can substitute the values of A and B into 6A minus 6B over B to see if this equals 5. All right, so let's do just that. Here we have 6. Our A is 11 over 7 minus our B is 6 over 7, and this is over our B again is 6 over 7. So let's see if this is going to equal 5. So let's multiply. 6 times 11 is 66. 66 over 7, then minus 6 times 6 is 36 over 7. So we can now remove this from the denominator and say this is divided by 6 over 7. Okay, let's proceed. Since I have a common denominator here, we can simply subtract them because I have a common denominator. Let's just pick one. So we have 66 minus 36 over 7. And now we can take the reciprocal of this. So we now have times 7 over 6. So when you take the reciprocal, what do? You simply change the sign from division to multiplication. Okay, so now let's go ahead and see what we can do with this. So 66 minus 36 will give us a 30. So right here we have 30 over 7, then times 7 over 6. Okay, so let's now multiply out to see what we're going to obtain. Right here we have 30 multiplied by 7 That should give us a 240. So on top, we have 240. Let me correct myself, please. 30 times 7 is 210 rather, not 240. So 210 over, and 7 times 6 is 42. So let's see if this equals 5. Now 210 divided by 42 is equal to 5. So this equals 5. And therefore, 5 equals 5. And that means that truly A is equal to 11 over 7. And then B is equal to 6 over 7. Thank you for watching this video. See you in the next video, and bye.